Good. Okay, so we're going to do a little bit more with lines and planes. So just as an example, let's find the angle between the planes given by these equations. X plus y plus z equals 1, and x minus 2y plus 3z equals 1. This is still the same section. Yeah, 13.5. So last time we developed all these equations for lines and planes, and we saw that a plane had a normal vector, and every point in the plane you can construct a vector that's perpendicular to the normal vector, and this is where we got this formula. And last night's homework was just a couple problems like this. But angle between the planes, that's new. How would you even define the angle between two planes?
The angle between the two perpendicular lines.
Exactly. The angle between the two normal vectors. The angle between the two normal vectors. Because angle between two lines, that makes perfectly good sense to us. You can imagine putting a protractor on that and measuring it. But if I have two surfaces, it's not entirely clear how I would measure that angle, or even if it was unique. But if I take the two normal vectors, then I've got a well-defined angle. So my solution is to find the angle between the normal vectors. And the nice thing about normal vectors is, from that formula we saw last time, the normal vector is just the coefficients of x, y, and z, because the plane is the dot product of n and r. So the normal vector for this first plane is 1, 1, 1. And the normal vector for the second plane is 1, negative 2, 3. So that's the nice thing about the plane equation. You can just read the normal vector right off. So now I just need to find the angle between these two things. Well, the angle is the cosine, right? And or the dot product. The dot product cosine gives me the angle. So the cosine of the angle is 1, 1, 1, dot product 1, negative 2, 3, divided by the magnitude. So the magnitude of 1, 1, 1 is going to be root 3. And the magnitude of 1, 2, 3 is root 14. So now we just need the dot product. The dot product on top is 1 and 3, and then minus 2. So 2 over square root 42. And if you take the arc cosine of that, you get theta is approximately 72 degrees. So it's a very straightforward computational problem. You just plug it into the formula. But the reason I want to show it to you as an example is because the initial question, the angle between two planes, it's not obvious how to solve that. And the big idea here is that the angle between two planes is the same as the angle between the two normal vectors. And that is a really important idea that comes up all the time. In the real world, whatever that is, this angle comes up all the time in 3D ray tracing, games, things like that. Because if you want to shade something realistically on computer graphics, you need to know the angle between the surface and the light coming in. So you know the direction that the light comes in, you have a normal vector to the surface, and whatever that angle is tells you how much light is reflected. So computer graphics cards, they're doing this computation, 5 billion times a second to get ray traced shapes. Yeah. Okay, another example we're going to do is, now I'm going to take two planes. Hi. And I know, I'll get everybody trained eventually. Thank you. I know, it's fine. It's just out there for the entire world to see. Carrie is the one running the camera out there. Hi, YouTube world. What I want to do now is find the line of intersection. So another different kind of problem, may not be obvious how to solve it. If I have two planes, how can they intersect? What are the different ways two planes can intersect? They cross, and if they cross each other, what does that look like? So it'd be one line, right? What else can happen with two planes? Exactly the same plane, right? Or they could be parallel. So no intersection, infinite intersection, and then one line. Those are the three options. So how can I find the line of intersection if I had an equation? It looks like I'm actually doing the same two planes here. So x plus y plus z equals 1, and x minus 2y plus 3z equals 1. Well, the algebra 2 analog of this is just finding the intersection of two lines. You can just solve for y, plug it into the other one, and get a coordinate. Here, my answer is not going to be a coordinate. It's still going to be an equation, right? A three-dimensional equation for a line. So I can't just solve one and plug it into the other. But what I can do is, if I could find 2 points that were on both, then I could find the line between them. So how can I find even 1 point that's on both? Well, setting it equal to each other is still going to give me an x and y and a z. It's not going to eliminate anything. But what I can do is I can just plug in a value. Right? Because if these are two planes, they're going to intersect, for example, at z equals 1. I just don't know what x and y are. Right? There has to be some x, y, z value where they intersect. So if z equals 1, that means x plus y plus 1 is 1, and x minus 2y plus 3z, 3 is 1. And that's a system I can actually solve, and it's going to be easy to solve. It says x plus y is 0, and x minus 2y is negative 2. So if I subtract these equations from each other, I get 3y is 2, so y is 2/3, which means x has to be negative 2/3. So 1 point that's on both of these things is 2/3, negative 2/3, and 1. Okay, so how can I find another point? Yeah, let z equal 0. If z is 0, then I get x plus y equals 1, and x minus 2y equals 1. Do the same thing and subtract these, and this one's even easier. I'm just going to get y is 0, and x is 1 is the solution to that system. So that gives me 1, 0, 0. So now that I have 2 points on the line, I can write the equation easily, right? Just pick the point and the displacement vector. So I'll erase this one. That means my line, which is, right, it's P1 plus t times, I'm making a mess, plus t times p2 minus p1. Right, that's our equation of a line in vector form. So let's just say it's 1, 0, 0 plus t times, and then the displacement vector there is going to be negative 1/3, negative 2/3, and 1. Oh, I did it backwards, sorry. Negative 1.
Oh, it's, yeah, exactly.
Which is the same as 1, 0, 0 plus t 1 to negative 3. Right, why can I do that?
It's just a,
Yeah, right. Same direction, so I just got rid of the fractions. Yeah. What's that? It's, it's interesting that it's 1, 2, 3, but I think it's just coincidence. I mean, that's 1, negative 2, 3, so the signs don't match and they're not even opposite of each other, and there's no relationship between that. So I think in this case it's just a coincidence. In general, you can't, just sort of look at those and immediately know the answer. Okay, so another fairly easy problem once you know how to set it up. The last one I want to do is derive a formula for the distance from a point to a line, or a point to a plane. Point to a plane. Point to a plane.
what part of the plane?
Ah, what part of the plane? Well,
Normal line.
the normal line. Exactly. There's a point, I want to know its distance to the plane. Obviously, there's infinitely many distances depending on which point that I pick. So the most common thing to pick is the shortest distance. So when I say distance from point to a plane, I really mean the shortest distance from a point to a plane. Convince yourself that's got to be the normal line.
You have to go straight down.
Exactly, straight down. If you go off at an angle at all, you just sort of be making a cone around this normal line, right, if you went off at an angle. So here's my point, and I have a name for it. I will call it P1. And let's say my plane is given by this equation, ax plus by plus cz plus d equals 0, and my point is xo, yo, zo. Okay. So we'll use all those coordinates in our formula. Well, we can solve this problem with just a little bit of geometry. And what I'm going to do is pick some point on the plane, like we did when we came up with the equation of the plane. I'm just going to call it P0. Any old point that satisfies that. And I'm going to draw that vector B. And B is P1 minus P0, okay, from one point to the other. Now, if that's a normal vector, isn't that a right triangle? because this is my point where I go straight down.
Right, but like, you just pick a random.
This point is random. There's only one of these because this is straight down.
And you create one
It doesn't matter
perpendicular
where it
to
is,
the
it's
plane,
still-
no matter which vector.
Yeah, exactly.
Yeah, the normal vector is perpendicular no matter
You just
where.
pick a point on the plane.
Just pick a point on the plane. Right. Right. Now the distance is going to be that length right there. And theta,
Your distance is the vertical or on the plane?
the distance is straight up and down.
Oh.
Yeah, straight up and down. And that angle in the top part of my triangle is the angle between two vectors. Theta is the angle between what two vectors? B and D is the same direction as N, the normal vector. The normal vector. So theta is the angle between B and N. And I know from trig over here that D is just the length of B times cosine theta. Well, now let's put these two facts together. Theta is the angle between B and N. Cosine of theta is going to be B dot N divided by length of B, length of N. Because that's the definition of dot product. So my distance is the length of B
Teachers, please pardon an interruption for some afternoon announcements.
times
This announcement is
cosine
for
of
any student
theta,
or teacher that
which
parks in the
is
parking lot behind the stadium where the Briarwoods band practices.
B dot
If
N
you have an after-school activity or
over
sports practice
length
today,
of B,
please move your car
length of
to
N.
another parking spot before 5. Also,
Okay.
a reminder to senior homecoming court.
Now what cancels out?
Please make sure that you report to the main gym tomorrow morning at 8:15. Do not be late. That is for the senior homecoming court. Also, the debate club will be out front selling pizza for $2 a slice. The
Okay.
following students, please report to the main office when the bell rings. Julia Bayshore, Jenna Graham, Zach Bentley, Brooke Lancaster, and Shannon Walsh. Those students, please report to the main office once the bell has rung. Everyone else, have a great afternoon, and we'll see you tomorrow.
B dot N over magnitude of N is just going to be, well, B is P1 minus P0. So that's XO minus X, YO minus Y, ZO minus Z. The normal vector is ABC. And the length of N, if the normal vector is ABC, then its length is A squared plus B squared plus C squared. Now, I know I kind of rushed through this. I'm going to skip a couple steps here just so I can give you the final formula. I know, time gets us. And I'll fill in the details next time. But this dot product, when you multiply that out, you get an AX, a BY, a CZ. All the other terms end up being the same as D. So it's over the square root.
Supposed to be squared? Yeah. No.
C squared.
On the bottom.
C squared.
Okay,
Yes. Yep. Okay, so that's it. Short one today. Thanks.